Hi Chem Gang. In this video we're looking at Skill Builder 11.6, which is the application of the ideal gas law. So up until this point in the Skill Builders we've been looking at how pressure, temperature, and amount of gas affects the volume. In Boyle's law we saw that volume is affected by pressure. So as pressure increases, volume decreases. And as pressure decreases, volume increases. This is an inversely proportional relationship between volume and pressure. In Charles' law, we looked at how temperature affects volume. And we see that when temperature goes up, volume increases, and when temperature decreases, volume decreases. So the relationship here is a directly proportional relationship. And lastly, with Avogadro's law, we looked at how volume was affected by number of moles, and we saw that as the number of moles increase, the volume increases, and blowing into a balloon is the example of how this works. So the more gas we add to the system, the greater the volume. If we take away that gas, the volume is going to decrease. We can put all of these variables into one law called the ideal gas law. And the ideal gas law looks like this. Pressure times volume is equal to the number of moles, the ideal gas constant, which we are given as 0.0821 times our temperature. So this constant, this ideal gas constant, is equal to 0.0821, and as it is a constant, it never changes. So it's liters times, or volume times atmosphere, mole times Kelvin. So we're going to be using this constant a lot when we're looking at the ideal gas law equation. Another thing to keep in mind is that pressure will always be in atmospheres, volume will always be in liters, moles or amount will be in moles, and our temperature has to be in Kelvin. So if any of our variables are given in a unit other than these, we will first have to convert them back to these units before we do the calculation. So in this case, we are given our volume is 8.5 liters of gas. We are given our amount, N is equal to 0.55 moles, and our temperature of our gas is at 305 kelvins. So far all of our units are fine. We just need to find out what our pressure is, and that will be in atmospheres. So we're going to use the formula PV equals nRT to solve for the P. So we're going to set this up, and we're going to have the pressure times our volume of 8.5 is equal to 0.55 moles times our ideal constant, which is 0.0821, and then times our temperature in kelvins, which is 305. So we get 0.55 times 0.0821 times 305 is equal to 13.77, and that's equal to the pressure times 8.5. We need to isolate the pressure, which means that we want to bring 8.5 over to this side by doing the opposite operation. So we're multiplying here, so the opposite to multiplying is dividing. That cancels out, leaving us with our pressure, but whatever we do to this side, we also have to do to this side algebraically. So that leaves us with our pressure is equal to 1.62 atmospheres. And that is the final answer to Skill Builder 11.6. Thank you for watching. Bye for now.